A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the Enclaps channel. Ring the bell button and open success. It's that easy.
Hello. Now let's move to another part of the circle. Here we will discuss about the chords and circles. Look at the figure given. Here we can see two diameters of circle. So here 4 radii are there. Here we know the diameters are meeting at the center. What happens when two chords which are not diameters intersect? Here the length of the chords are not equal, right? Also they are not passing through the center. Also they are not perpendicular to each other. Still there are some relations in between them. Now join AC and BD. Now we got two triangles, triangle APC and triangle BPD. The smaller arc BC is making angles at the point A and D, that is angle CAP and angle BDP. These two angles are same, that is when an arc is making angles on other arc, then those angles must be same. So here angle CAP is equal to angle BDP. Now look at the angles APC and angle BPD. Angle APC must be equal to angle BPD as these two angles are opposite angles. Similarly, the arc AD is making angles at the point C and B. So angle ACP must be equal to angle DBP. That is angles of the triangle PAC is equal to angles of the triangle PDB. If angles of one triangle is equal to angles of other triangle, such type of triangles is known as similar triangles. In similar triangles, the opposite sides of the same angles must be proportional. Here, the opposite side of angle CAP is PC. The opposite side of angle PDB is PB. Similarly, the opposite side of angle ACP is PA and the opposite side of angle PBD is PD. As the sides are proportional, it can be written as PC is to PB is equal to PA is to PD. That is, it can be written as PC divided by PB is equal to PA divided by PD. By cross multiplying these values, PA into PB is equal to PC into PD. Here, PA and PB are parts of the chord AB. Similarly, PC and PD are parts of the chord CD. That is, if two chords of a circle intersect within the circle, then the products of the parts of the two chords are equal. If we consider each parts of the chords as sides of the rectangle, then the product of these sides will give the area of two different rectangles. The product of sides are equal, so the area of such rectangles will be also equal. That is, if two chords of a circle intersect within a circle, then the rectangle formed by the parts of the same chord have equal area. Now look at the figure. The side EP in a rectangle APEF is equal to BP. Similarly, the side PG in rectangle CPGH is equal to PD. We can now solve problems on area by using this property. Consider a rectangle of length 5 cm and width 3 cm. The area of this rectangle is 5 into 3, that is 15 cm square. Now we want to draw another rectangle of area 15 cm square with length 7 cm. What will we do? If length is 7 cm, then the width must be 15 by 7, right? Because the area given is 15 cm square and length into width will give the area. From there, width will be equal to 15 by 7. Further simplifying, it can be written as 15 by 7 is equal to 2 1 by 7. By using a scale, it is not possible to draw this length. So we can draw this by using the properties we learned. Draw a line of length 8 cm. Now mark a point which is 5 cm from one side. From this point, mark another point which is 7 cm away. Now draw a circle which passes through the end points of the first line and the new point we got. Now join the line as shown. The new line obtained is the width of the rectangle which we are going to draw. By this method, we can easily find the width of the rectangle without using a scale. If we had drawn a perpendicular line of length 7 cm to the initial line which is shown here, the solution would have been easier. So in algebraic terms, how can we solve this? Draw a rectangle of length A and breadth B. Here we want to increase one side a little and draw a rectangle without changing the area. Just assume the length we want to increase is C and assume the new width as X. So the area of new rectangle will be A plus C into X, that is length into breadth. The area of initial rectangle is AB. Both the rectangles have same area, then it can be written as A plus C into X is equal to A into B. Now by calculating the value of X, the width of new rectangle will be obtained. Now we are going to apply this concept geometrically. Draw a rectangle of length A and width B. So first we extend the bottom side of the rectangle to left by B distance and the left side downward by A plus C distance. Now mark the points P and Q. Now draw a circle through the 3 points P, Q and B. For drawing this circle, draw perpendicular bisector of the line PQ. Also draw the perpendicular bisector of the line BQ. The meeting point of these perpendicular bisectors will be the center of the circle. Now consider the distance between the center and point B. Take this distance on compass and draw a circle. This circle will pass through all the points P, B and Q. Now this circle is intersecting the side AD. The part of the side AD cut by this circle is the width of the required rectangle. The new rectangle drawn by using this side as width will have the same area as that of the previous rectangle. Now let us consider some special conditions. In the picture, given AB is the diameter of the circle and CD is the chord perpendicular to it. The perpendicular from the center bisects the chord. So we can say that PC will be equal to PD. We already know the property, that is PA into PB is equal to PC into PD. Here PC is equal to PD. So substituting PC in place of PD will give the relation as PA into PB is equal to PC square. That is, by words, this can be written as the product of the parts into which a diameter of a circle is cut by a perpendicular chord is equal to the square of half of the chord. In geometrical language, this can be put like this. The area of the rectangle formed of parts into which diameter of a circle is cut by a perpendicular chord is equal to the area of the square formed by half of the chord. We can use this principle to change a rectangle to a square of same area. Now let us draw a square of area 6 cm square. Here 3 into 2 is 6. So first consider a rectangle of length 3 cm and width 2 cm. By using this rectangle, we can draw a square of area 6 cm square. First draw a line of length 3 cm. Now extend this 3 cm line to another 2 cm on the right side as shown. Now 3 plus 2 is 5 cm. Draw a semicircle with diameter of 5 cm as shown here. Now from the point B, extend a line upwards till it meet the semicircle. Now the length BD will be the side of the square. Here we use the property BD square is equal to AB into BC. Here the length of the side of the square is root 6 cm. That is, this property can also be used to draw lines which have irrational lengths. In this chapter, we learned about circles and its properties. All the concepts discussed here is very important. All the activities related to this chapter is given under the icon Maths Lab. Thank you.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ Enclaps, the learning app.